Are you ready? Let's make some jam.
In this lecture, we will learn how network operates. Please pay close attention, as you won't be able to protect your network as well as launch successful cyber attacks against target network if you don't understand how it functions. In the network, there are a couple of key components that we need to analyze. These are internet packets, local and gateway IP addresses, MAC addresses, DNS, and ARP tables. In this lecture, we will cover all of these components and elaborate on how they function together. We will go through everything sequentially. Let's start with internet packets. These guys are little pieces of data that circulate through the network. They include information like your username, passwords, Word document, video or picture, or everything you see in your browser. Basically, anything you send and receive in the network is distributed using the internet packets. Sometimes they are also referred to as data packets. Just as we do in real life, when we ship a package to someone, we need to indicate our own and receiver's addresses, right? In case of network communications, IP addresses are used to indicate who is sending the data packets and who needs to receive them. For instance, when you log into Facebook, your computer creates data packets that include your username and password. These data packets are sent to Facebook's server's IP address. When Facebook server processes your request, it sends you data packets back that include your personal profile page. Sounds simple, right? Well, actually this process is a bit more complicated, since the data packets have to travel through various instances in order to reach their destination. Remember, in the beginning of this lecture I mentioned that there are two types of IP addresses, local and gateway. Both play a significant role in terms of precision of internet packet routing. To make things clearer, let's observe the following infographic. What you see here is a typical network you probably have at home. Right in the middle of the connection stands the router. To the left you see devices that are successfully connected to the router. These are desktop and laptop computers and mobile phone. Each device in the local area network, including the router, has its own local IP address. These local IP addresses are assigned by the router. For example, when a new device successfully connects to the router assigns a local IP address to it. So, everything you see to the left of the router, including the router itself, is called local area network. Please note, sometimes people shorten local area network to LAN, or simply call it subnet. So local area network, LAN and subnet are synonyms. To the right of this infographic you see a router's connection to the World Wide Web, or the Internet. The router gets internet from your internet service provider. This could be Verizon, AT&T or any other that you might be using. At the same time, your internet service provider assigns a gateway IP address to your router. This means that your router has local IP address and gateway IP address at the same time. The local is used to communicate with the devices that are on the left of the infographic, or the subnet devices, while the gateway IP address is used to communicate with the internet. Remember, the only device that has direct connection to the internet is your router. All other devices get connected through the router. This means that no matter what device from the left reaches the internet, all of them are going to have same gateway IP address, because the connection flows through the router. Now I will show you an example and things will become clearer. Let's imagine that you want to view Facebook newsfeed from your laptop. Probably you are going to type facebook.com in the URL field of your favorite internet browser and hit enter. Right at this moment your computer generates data packets and request is embedded in this packet saying, "Please open website facebook.com." Now observe how these packets travel. Firstly, they go to your router. Router analyzes these packets and says, okay, so a request to open facebook.com comes from a computer with IP address 10.0.2.3. I need to redirect the request to facebook.com now. Just in case you didn't know, facebook.com is actually an IP address. A special service called DNS translates Facebook's IP address to facebook.com. We will elaborate on this when the necessity comes. For now, let's just follow the data packets. So, after the router analyzes the data packets, they are redirected to Facebook's server. Facebook server analyzes the request and sends back data packets that include your Facebook page to the gateway IP address of your router. So, Facebook doesn't actually see local IP of the device that made a request. However, your router knows that request came from laptop and not from another device in the network. Thus, it redirects the data packets to a computer that made a request. As a result, you see your Facebook newsfeed. So far, so good. Now let's imagine that after your laptop made the request, it suddenly turned off, while another desktop connected. You see, by default, router allocates IP addresses dynamically. This means that once a device exits the network, the other device might get the same IP address that previous device had. Now I'm talking about local IP addresses, of course. The newly connected desktop computer might get a local IP address that your laptop had. The question is, what will happen to the packets that return from Facebook in the meantime? Will they go to the newly connected desktop with the same IP address that your laptop had? Nope, they will not. Why? Since the router will only send these packets to the computer that actually requested them. But the newly connected desktop has the same IP address, right? How does the router know that it's actually a different computer? It's because your router uses not only IP addresses to identify the device in the local area network, but also MAC addresses. I guess it's the right time to explain what are MAC addresses and how they function. Well, you probably knew that each network-capable device has a physical part that is responsible for the network connection. We call it network interface cards. They come in various shapes and forms. Usually these parts are integrated or hardwired on the motherboard of your device. Each network interface card has its own MAC address. Thus, MAC addresses are unique to every existing network interface card. According to the plan, no two network interface cards in the world have the same MAC address. Together with IP addresses, MAC addresses serve as identifiers in the local area network. The router and every other device in the local area network knows MAC address of all other devices in the same local area network. Now let's visualize everything I said. When a new device successfully connects to the router, it sends internet packets. If we translate information in these internet packets to human language, information sounds like this. Hi there, I'm now connected. My MAC address is A4:CC:T1:T4:BA::C2. Please give me a local IP address.
We're almost there.
The router replies, "Hi, my MAC is A1:A2:A3:B1:B2:C3. I'm assigning you local IP address 10.0.2.4. Your gateway IP address will be 144.144.155.12. I will also send information about your IP and MAC addresses to other devices in this local area network."
Let's dive.
So, now every device in this network knows local IP and MAC addresses of newly connected device. Information about correlation of local IP addresses and MAC addresses is stored in places called ARP tables of each device on the same subnet. This information gets refreshed every once in a while so that each device knows what other devices are connected in the same subnet. Naturally, this process occurs automatically, so user doesn't actually know what is happening. Based on the information stored in the ARP tables, the router knows that packets that returned from Facebook belong to other computer, even though the newly connected device had the same IP address. Even with having same local IP address, the laptop that made the request and the newly connected desktop had different MAC addresses. The router quickly checked whether MAC address of the computer that made the initial request matched the MAC address of the computer that has the same IP address. Since MAC addresses were different, router didn't redirect the internet packets intended for the laptop to the desktop computer.
Let's start over.
So, Now you know that your router isn't just a piece of dumb plastic. It's actually a complex device that does a lot of stuff in the background. Probably you've heard that hackers can intercept data packages that are not intended for them. Well, for this purpose they use ARP spoofing technique, which corrupts the ARP tables of the targeted devices. But this is the topic for another lecture. Now it's more than sufficient for you to understand the principles of how network works, and that hackers can in fact bypass network security and redirect traffic to their own devices. You can also find out more about IP addresses, MAC addresses, network interface cards and internet packets in the resources of this lecture. With this said, let's finish this lecture. Things are about to get very interesting, so be sure to stay with me.
Rewind.